There he is again. Kyle. Did you guys come to chat or did you come for the review? Okay. I will be getting started in a few minutes. I'm not going to. I'm not going to waste a ton of time. Um, Maybe until the end. So, is that the Rock? What are you talking about? Oh, Joe. So I'm gonna get some water, and then I'm gonna put the link to the worksheet in the description of the video. I'll do that when I get back. And then we will get started. So, BRB. Go sit next to brother. What is the matter? What's the matter? Okay. Okay. Is this website okay to use as a calculator? What website? Actually, no, I'll keep that there for a minute. And I am going to. I'm gonna figure out how to get that worksheet on here while he tries to tell me what website he's talking about. I don't know if he will tell us what website he's talking about. Okay, save that. Saving, go to my drive. Recent files. Is this the file? Yes, it is. Okay. Huh. Copied. Oh, here we go. And there's Robert. I think it's blocking me from writing the site because of spam or something. No, I don't. It shouldn't do that, Joe, only because since I'm a moderator, and Kyle could say that too, um, since Kyle's a moderator as well, he and I should be able to see what anyone's trying to post. Regardless. I'm almost there. I just need to put the link in the description. Here we go. and then I can get started. Into the worksheet. Boom. And save. All right. Yeah. If you guys refresh the stream, then in the description of this video should be the link to the worksheet that I'm referring to. Yes. If you refresh the stream, in the description of this video should be the link to the worksheet that I will be working on. So you'll know exactly what problem numbers I am referring to. There we go. And Kyle just put the link into the chat, like a moderator that he is. So yeah, if you want to know exactly what I'm referring to, those are the problems. I gotta get rid of this one window. There we go. Boom. Okay, so you guys had a worksheet due for me last week that I just went through this morning and added a ton of comments to as many people within reason, of course. But I was able to go through and see where a lot of the mistakes were. What I would like to do in terms of this rational practice is I would like to go over those problems, and if you have any questions in regards to a problem that I'm going over, ask it here and now in the stream. Oh, wow, goodness. Yeah, Joe, whatever link you just put, I tried searching what that link was, and it Barnegat Schools has it blocked, just so you know. I can't even get to that link as well. So no worries. But anyway, so I'm just going to get started. Again, there will be... oh, it's Steam? Whatever. I don't care. But I will be putting timestamps in the description per the individual problems that I'm going through. But what I had for you guys was I had you do numbers... just double check here. Come on, you. I believe it was numbers 1 through 6 and numbers 16 through 21. And I said to pick 2 and pick 2 from each section. And that's what, the vast majority of you did. So we're good. I'm really glad I didn't get to that link either. But anyway, I'm going to get started. So number 1 on this particular problem, it was 9a squared b cubed over 27a to the 4th b to the 4th c. Now, if you watched my lesson on these problems, then you would have seen that there's no adding and subtracting done for these. So we can go ahead and just simplify term for term. Since everything is being multiplied and divided, there is no addition and subtraction. We can simplify like a regular fractional number. Like, for example, 9 over 27. 9 over 27, you can simplify that fraction by dividing both the top and the bottom by 9. That would leave you with a 1 over 3. And again, we're going to write out the final answer in a little bit. We can go through the a variable as well. The a variable, there's an a squared on top, there's an a to the 4th on the bottom. Now, a squared is just a times a to the 4th is just a times a times a times a. There are 4 on bottom, 2 on top. Well, the 2 on top would cancel out with 2 on bottom, leaving you with an a squared on bottom. You could also think of it as there's only 2 a's being multiplied on top. There are 4 a's being multiplied on bottom. Who wins? The bottom wins, but they win by 2, which is why a squared is on bottom. Do the same thing with the b's. There's 3 on top. There's 4 on bottom. The bottom wins by 1. C just stays exactly where it is. Ultimately, the final answer to this problem should have just been something like that. This is what they call a monomial problem because there's nothing being added or subtracted within this process. A similar thing happens. To number 2, except on number 2, you are gonna be distributing an exponent. Now, I asked this question in class a lot. Are we allowed to distribute that exponent? The answer is yes. Why? Because there is no addition or subtraction going on within those parentheses. Since there's no addition subtraction, we are allowed to distribute that exponent. But keep in mind that the distribution of that exponent goes not just to the m, not just to the n, but also to the 2. So please be aware of that. That's really a 2 cubed, which is 8 now. N cubed to the 3rd power, you would have to multiply those exponents. N squared to the 3rd power, you would have to multiply those exponents. Then we are going to simplify just like number 1. The negative, you can keep the negative where it is. Technically, that negative could come out front if you wanted it to be, which is fine. But look at the 8 over 18. The 8 over 18 both can be divided by 2, like a regular fraction. 8 over 18 becomes 4 over 9. Again, that negative is just on the problem. That negative could come out front. That negative could be moved to the top. You can do whatever you want with that negative. Just keep in mind that negative is still in your answer. N to the m to the 9th over m to the 5th. Top wins by 4. It would become m to the 4th. N to the 6th over n to the 4th. The top wins by 2. There are a number of different ways to do this problem. Now again, I'm just going to put that negative here for the sake of argument. But there's a number of different ways to do this problem. You just have to be careful with how you go about doing it. Now, after this problem, and I'm looking at the worksheet right now, I believe if you're just looking at numbers 1 through 6, only 1 and 2 were these monomial type problems. Only numbers 1 and 2 were those monomial type problems. When we get to number 3, then we're going to be dealing with binomials. Let's just see what happens. Yeah. Come on, you paper. There we go. Now I'm looking at number 3. On number 3, you're dealing with a binomial on top and a binomial on bottom. If you're thinking Tucker method, which is what I want everyone to be thinking for the most part, you really got to remember step 1. Step 1 of the Tucker method. Step 1 of the Tucker method, as I've tried to remind people over and over and over again, GCF. GCF. With GCF, if I'm just looking at the numerator, the top of the fraction, no, Kyle, not A times C. Let's do GCF. Make your life easier. If I look at the top of the fraction have a 10 and a 15. Both have a 5 in common. They also, y squared and a y, they both have a y in common. Because of that, on the top of the fraction, I can divide a 5y out of both terms. As a result, it becomes 2y plus 3. On the bottom of the fraction, I'm going to do something very similar, where I'm also going to take out a 5y. Because they both have a 5 in common and they both have a y in common. Now, when you divide, be very careful. This first one, yes, just becomes 7y, but then the second part doesn't just go away. 5y divided by 5y. There's a minus 1 there. As a result, the 5y's do indeed cancel each other out. Since the top of the fraction does not match the bottom of the fraction, we're done here. Joe, you're just saying random things in the chat that are coming to your mind. Anyway, let's talk about number 4. And again, I'm going through these in quick succession. Again, if you have any additional questions, please ask in the chat. Otherwise, this is a review video for those that are watching it. Timestamps in the description. 2k squared minus k minus 15 over k squared minus 9. I'm looking at this problem, and I know that I definitely have to factor. I have a quadratic on top. I have a quadratic on bottom. What do I do? I'm going to do the Tucker method. Now, just for the sake of argument, I'm not going to do the Tucker method for every single one of these review problems. I may just kind of bypass most of the Tucker method. But right now, I would like to focus on the Tucker method for this problem, the numerator. I'm sorry, I'm looking at the chat, and I have no idea what's going on here. I'm going to hide Joe's comment for fun. There we go. Don't make me put you in timeout, Joe. Anyway, back to this. If I'm looking at the numerator, I'm going to put a little sidebar over here. 2k squared minus k minus 15. I can't take out an a times c. I'm sorry, I can't take out a GCF. I'm losing my mind. But you can do an a times c to get negative 30. Your two magic numbers, they would have to multiply to negative 30. They would have to add up to negative 1, meaning the b value in the middle. That would be negative 6 and positive 5. Nick X, Kyle, he's got all of the eraser caps and the pencils and the gum, apparently. So anyway, back to this. Negative 6, positive 5, a 2k, and a 2k. You can simplify. You end up with k minus 3 and 2k plus 5. It's that little sidebar Tucker method that I was able to do for this problem. Now, on the bottom of the fraction, you can do the Tucker method again. K squared minus 9. You can't take out a GCF. Your a times c would be negative 9. Your two magic numbers would be 3 and negative 3. Nothing would simplify. But that's what the bottom of the fraction would turn into. Now, the k minus 3's, of course, based on all of the videos that I've done, the review videos that I've done, the k minus 3's cancel each other out. Nothing else cancels. In order for something to cancel, it would have to match exactly on the top and bottom of the fraction. That's the answer. Now, the system that I've put into place for simplifying these types of problems, if you do the GCF first and then go through the factoring, everything should take care of itself. You wouldn't have to worry about, you would not have to worry about whether or not, oh, did I miss something? As long as you do it in that particular order. Take out the GCF first, and then kind of see where it goes from there. Okay, number 5. See if I can fit it on this page. I can. I think I can. I think I can fit it on this page. 25 minus v squared over 3v squared minus 13v minus 10. My biggest suggestion for number 5 is to rearrange the top of the fraction so that the v squared comes first. But keep in mind, that's a negative v squared. So you're going to want to take a negative 1 out as a greatest common factor. On number 5, I'm going to repeat that. On number 5, rearrange the top of the fraction, but keep in mind that your v squared is negative. It's a minus v squared. In order to do this problem correctly, I would suggest taking a negative 1 out as a greatest common factor. So what that looks like to us is this. Negative parentheses v squared minus 25. This is what the top of the fraction should turn into. It would make your life 1,000 times easier if you factored out a negative 1, just kind of left it off to the side temporarily, and then factored the v squared minus 25. If you factored the v squared minus 25, you would end up getting v minus 5, v plus 5. Again, by going through the Tucker method. Just leave that negative out front as a greatest common factor. Just leave it. Now, you can do Tucker method again with this 3v squared minus 13v minus 10. No GCF to take out. I'm not going to write it. I'm just going to verbalize it. But there's no GCF to take out. A times c would get you negative 30. The two magic numbers would be negative 15 and positive 2. Put them into the t-chart. 3v and 3v up top. After you simplify, on the bottom of the fraction, you should be getting a 3v minus 2. I'm sorry, 3v plus 2. It should have been a positive 2. And a v minus, I want to make sure I get this right, 5. Yes. And you can always double check yourself. 3v squared, negative 15v, positive 2v in the middle, negative 10 on the end. Everything works. Again, that would be going through the Tucker method to go from this 3v squared quadratic to these two factors. The v minus 5's cancel. Nothing else does. Technically, you can leave your answer just like this. And that would be acceptable for number 5. That would be perfectly acceptable. You can leave the negative out front. That's completely up to you. Oh, you have a bowling ball for me after this quarantine? If bowling even exists, people are going to be wanting to go back to normal. Tropical pearl. Hey, why not? All right, let's talk about number 6. This is the last problem from the top half of the page, and then we're going to be getting to some more of the difficult problems as we go along. This is number 6. Number 6, a lot of people kind of stumbled on, the ones who chose to do this problem, because they forgot to take out a greatest common factor, or after they took out the greatest common factor, they didn't know what to, they couldn't simplify it from there. First and foremost, the top of the fraction, just the top of the fraction, there is an x squared that they all have in common. Once you divide out that x squared from the top of the fraction, you end up with x squared plus x minus 2. Take the GCF out of the bottom. On the bottom, there's an x cubed. And when you take out that x cubed, you are left with an x minus 1. That's just the GCF step. Now, x squared over x cubed, you're going to have to simplify like we did with the monomials earlier. We'll deal with that in a moment. We still have to factor this remaining quadratic, again, using the Tucker method. If you were to factor that remaining quadratic, you would end up with x plus 2, x minus 1, again, using the Tucker method. Some people I saw were using a grouping which is fine. Grouping's not something that I taught, but it ends up making the problem a lot slower, a lot more work if you decide to go ahead with grouping. Again, grouping is perfectly fine. You can do grouping. It's just that it can be slightly annoying. But I digress. The x minus 1's cancel, as you would have hoped. The x squared over x cubed. The bottom wins by 1. Ultimately, this is your final answer. This is some... Sorry, I'm reading Joe's comment. Joe, you should be here to learn. How much for mod? I don't know. Kyle, how much did you pay? Oh, I'm not doing 7. Not doing 7. That was the top half of this worksheet. We're working on the bottom half now. Oh, nice. Cool. Yeah, I'm pretty sure it would be. Anyway, let's jump down to number 16. Do some more difficult problems. Again, timestamps will be in the description after I'm done here. I'll go through it this afternoon. And I'll put in some timestamps so that you don't have to search through this video for what you need. Instead, you can just jump straight to the part that you're looking for. Here's number 16. On number 16, you have two fractions being divided. I'm going to have to eventually turn that division into a multiplication. I am going to have to take out GCFs. I'm going to have to do all of that. And I'm going to have to factor some quadratics out. In fact, after I take out the GCF out of the 6x squared plus 12x, after I take out this GCF, it won't be a quadratic anymore, because I'll take out both a 6 and an x. But I am going to have to factor this. So let's do that. Took a GCF out of the top left. Factored the bottom left using the Tucker method. Keep, change, flip. Oh, I'm looking at Nick's comment. See, the thing is, calculators are a dime a dozen, dude. If you have an Android phone, I would suggest downloading. See if it will actually type into the chat. There we go. I would suggest downloading Wabbit Emu if you have an Android phone. If you have an Android phone and download Wabbit Emu, then you can easily get an emulator of graphing calculator. It really is fantastic. It's one of the greatest things ever. I have a TI. I can get TI whatever I want, but I use a TI 84. It's pretty fantastic. Anyway, back to this problem. Again, GCF out of the top left. Tucker method out of the bottom left. Keep, change, flip the division into a multiplication. Then I'm going to take out a 6x as a GCF here. If I take a 6x out, I'm left with x plus 2. I see this is going to be hard to get. How about wax erasers with your name on it? No! I want a statue with my name on it. Anyway, back to this. I can take out a 4 as a GCF down here. Now, if you notice, up to this point, I have not canceled anything out. All I focused on is taking out the greatest common factor out of 3 of these things and did the Tucker method on the bottom left. Bronze. I wanted out of bronze, Kyle. Get to work. Anyway, start canceling some junk out. Oh! I made a huge mistake. Anyone notice my huge mistake? I'm going to wait here until somebody mentions my huge mistake. I'll give you 30 seconds to figure out my huge mistake. one notices my huge mistake? All right, fine. Kyle, what's that rap song that you like to sing from last week? Too much pressure. What's the rap song that you sung last week? Or that you rapped last week? Or that you tried to? And it was, yeah. No. Oh, you're trying to get the link now. Okay. He's going to post the link in a moment. I know what he's doing. But it's keep, change, flip. I never did the flip. That was my mistake. I never did the flip. I kept it. I changed it. I never flipped it. There he goes. There's Kyle with that link. So let me flip it. Much better. I had to flip it. Kyle, that rap video is coming handy. It's pretty fun. It's also got fish in it somewhere. Now we can start canceling junk out. The x plus 3's cancel. The x plus 2's cancel. Furthermore, check this out. The 3 and the 4 would multiply to give you a 12. But on the bottom, there is a 6. So the 3 and the 4 would be a 12. The bottom would be a 6, and you'd be left with a 2 on top. What do you call an elephant that doesn't matter? I hope this punchline is worth it. Oh my gosh. Joe, I will have you know that I'm probably going to be stealing that joke and not attributing it to you. Anyway, writing the answer out. On the top of the fraction, everything canceled except for the 2. On the bottom of the fraction, keep in mind, looky right here. Look what I'm pointing at. That x is still there. On the bottom of the fraction, that's what I end up with. That x was still there, ladies and gentlemen. What did the bowling ball pin say to the bowling ball? Somebody give Nick a GG in the chat. Also, Joe, what's the answer to your question? All of a sudden, there he goes. So what's the answer to Joe's question, though? What did the bowling pin say to the bowling ball? Yeah, I'm going to hide Joe's response. Oh my gosh. All right, next problem. Let's go to number 17. Let's move this thing along. That's a good reminder for everyone to subscribe and ring that bell if you haven't already done so. Here's number 17. 2s squared minus 7s minus 15. It's going to take up a bit more room, but that is okay. Over s plus 4 squared divided by s squared minus 10s plus 25 over s plus 4. Anyway, back to this. One of the things you got to realize on this problem, you cannot distribute that square. You can't. You're not allowed to. You could do s plus 4 times s plus 4. But don't multiply them back together. Don't. The reason why you shouldn't is because the whole first step of this thing is factoring. Why would you factor it out? Or I'm sorry, why would you multiply them together and then refactor it out when it is already factored? Maybe I can. We'll see. Remind me. I have a 4x4 here, but I have another cube somewhere else. Anyway, back to this. Don't get me distracted with cubing. So, I'm going to factor this top part. Now, this top part, again, Tucker method. Can't take out a GCF. A times C is negative 30. Two magic numbers are negative 10 and positive 3. You're going to have to simplify in the t-chart. If you did that, you would end up with a 2s, what are my two magic numbers? Negative 10 and positive 3. Negative 10 and positive 3. There we go. That's what that thing should have been. On the bottom left, just write it out as an s plus 4, s plus 4. Don't multiply them back together. I'm going to follow Kyle's advice. Keep, change, flip. Keep, change, flip. Then I'm going to have to factor the s squared minus 10s plus 25 into an s minus 5, s minus 5. Please try to not confuse the s with the 5. There's no great way to write the variable of s. Really isn't. But then junk starts canceling. This s plus 4 and this s plus 4. Only 1 for 1. This s minus 5 and this s minus 5. Again, only 1 for 1. Nothing else cancels. Joe, you can actually highlight and copy and paste into a thing. But yeah, ladies and gentlemen, nothing else cancels as a result. This is what we get. That's all you can do. Nothing else can do it. I'm watching on my tablet. Okay, too much information, Joe. Too much information. Let's talk about number 18. We're almost there, ladies and gentlemen. I didn't want this video to be super long. I just wanted it to be informational from top to bottom, especially since you're going to be working on a minor for me on the computer. Number 18. 9 minus a squared. There we go. Over a squared plus 5a plus 6 divided by 2a minus 6 over 5a plus 10. It's number 18. Just double checking my numbers, making sure they work. No, I said after. Oh, I meant after I was done with all my problems. Kyle again with the cube change flip. Okay. How about after this problem? We'll do it after this problem, and then I'll continue. Go ahead. Your tears fuel me. Anyway, for this problem, ladies and gentlemen, you have a 9 minus a squared. It would be in your best interest to turn those around, make it an a squared minus 9, but you have to factor out a negative 1. That is a negative a squared. You could do a little side note up here, negative a squared plus 9. Take out a negative 1 to make it a squared minus 9. That may be in your best interest. I would suggest doing that. I'm also going to keep change flip based on Kyle's suggestion. Now, if I did take out that negative 1, that a squared minus 9 would become a minus 3, a plus 3, again, by way of the Tucker method. The bottom left, Tucker method once again, a plus 2, a plus 3. Keep change flip based on all that stuff that Kyle has been saying. This 5a plus 10 would go up top, but I am going to take out a GCF of 5. This 2a minus 6 would go on bottom based on that flip, but I am going to take out a 2. Now, number 18 was an interesting problem, because if you factored everything correctly, if you took the negative out of this first term and then did the a squared minus 9 and factored it, if you did the Tucker method, a squared plus 5a plus 6, factored it. if you take out a GCF out of the top and bottom here, but of course do the keep change to multiplication, flip, the a plus 2's would cancel, the a plus 3's would cancel, the a minus 3's would cancel. Don't forget the -1. Your final answer just ends up being the fraction -5/2. It's a great problem. Fantastic problem. Right. I wrote number 19. They wanted me to do a cube. Let's see here. Here we go. All right. I'm just going to scramble it real quick. And I will do you one better. I will just simply do it one-handed for the sake of argument. There we go. Let's check my battery life. Okay, one-handed. You ready? Just looking around, looking around, looking around. Got him. And go. Ah, totally dropped the cube. That's going to ruin everything. Or will it? No, it won't. Oh, no, it totally did. All right, fine. I'll fix it in a moment. Let's just do it this way. There we go. Yeah, I did the wrong algorithm at one point. Y'all happy? So, Nick, I can do it with my feet, which I'm not going to show you. Watch, I'm going to get a link here. I'm going to get a link, and I'm not going to show you the feet thing because I don't have any video of it, but I do have a record of me doing it once. There we go. Copy and paste. Boom. If you click that link, it'll take you to my World Cube Association page. And if you scroll down to the bottom, it'll show you the one time that I got an official feat solve in competition. So, anyway, you can look at that at your own time. Doing number 19, just for the sake of argument. Again, timestamps. People won't have to worry. There was a bit of an issue with number 19 in the fact that some people completely bypassed the work that they could have done or should have done with number 19. They just needed to be very careful with what it was they were supposed to do. There we go. Yeah, it's getting very weird in the chat. Thank you, Kyle. But to this, ladies and gentlemen, I'm looking at this problem. The way that I need to think about this problem is that it is a giant division problem with two little fractions. Well, keep in mind, Nick, 22 is how many people at that one particular competition. In the world, that's a whole other story. In the world, where's the feat solves? Oh, that's right. They took them out. Yeah. On my current personal records, they don't have any of the feat solves, only because they got rid of it as an official competition. But anyway, to this problem, ladies and gentlemen, this giant division bar in the middle, I'm going to rewrite it with a division symbol. Then, as Kyle is always fond of reminding me, I'm a keep, I'm a change, I'm a flip. And as a result, those X's cancel each other out. He's ready with that link. Look at him go. But those x's cancel each other out, and nothing else does. You could leave your answer like this. Perfectly acceptable. 2 more problems. We got numbers 20 and 21 to do. 20 and 21. Nick, the thing you got to know about that kid, Daniel, his name is Daniel Rose Levine. He, at multiple times in his life, had held the average and single world record. His single world record, I think, was down near 16 seconds. Anyway, number 19. Wait, number 19? No, number 20. Number 20. Number 20, I had marked down a lot on the review, or on the worksheet and people's comments, because on number 20, this is the one that most people ended up screwing up. Even though it looks simple enough, they ended up missing something quite nice. Now, I'm looking at this problem. Again, this giant division sign in the middle, I'm going to replace it with the division symbol. This really should be x squared minus 9 over 4 divided by 3 minus x over 8. I'm going to keep, change, flip, but keep in mind this important thing. I'm going to turn this 3 minus x around so that it is negative x plus 3. Then I'm going to take a negative out as a GCF. It really should be this. That's going to be important later on. I'm going to factor out the x squared minus 9. I'm going to change the multiplication. And I'm going to flip the second fraction. Let me just recap exactly what the heck just happened. First, the big division symbol in the middle becomes this division sign right here. The 3 minus x, you need to change those around to be technically a negative x plus 3, but then I'm going to take a negative sign out as a GCF, as we've done on multiple problems before. I'm going to keep, change, flip, but I am going to factor out this x squared minus 9 using the Tucker method, x minus 3x plus 3. There's the change. There's the flip. The x minus 3's cancel. And this 8 over 4 reduces to a 2 over 1. Now, dividing by a negative 1 doesn't do anything. I'm sorry, dividing by 1 doesn't do anything, but that negative is indeed still there. On the top of the fraction, there is still a 2 times x plus 3, but that negative is still on your problem. Number 20 was a weird problem. Finally, let's talk about number 21. Now, I say finally, but I do have a couple additional problems that I would like to review with you involving addition, subtraction. We'll deal with that in a little bit. But this problem was great. This problem was great. Just trying to zoom in on here, right? There it is. X cubed. Hold on, I'm sorry. I have to zoom in on the right problem. There it is. Okay. It was x cubed plus 2 cubed over x squared minus 2x, the whole thing, big division symbol, x plus 2, the whole thing cubed, over x squared plus 4x plus 4. Now, I am happy to say, I'm not ignoring it, it's just I'm trying to get through my work. I am happy to say that most people skipped number 22 because there was a problem on number 22. There was a problem on it that caused it to be not nice of a solution, very not nice solution. I would say that if you were not able to do number 21, like if you tried it, I probably should not have done it. And the reason why, maybe I can do this in a red pen. The reason why this problem was not so nice was because of this up here. Yes, I'm happy to say that almost nobody did number 21. I didn't do 22 too. No, you mean number 21. But this x cubed plus 2 cubed is probably what screwed people up, because that has to be factored in a very particular way, and it's not something that you really have to worry about for where you guys are at right now. For the sake of argument, x cubed plus 8 over, I'm going to factor some junk out now, x minus 2 divided by, this is really an x plus 2, x plus 2, x plus 2 divided by x plus 2, x plus 2. I just decided to factor a whole bunch of stuff out. Again, this is not a problem that you're really going to have to worry about. I'm going to do more actual examples that you will have to worry about in a minute. Just for the sake of argument. Hapa, 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 hapa. They all canceled each other out, which was kind of nice. Yes, we're going to keep change flip. Kyle, where's my link? Kyle, not on the ball. There he is. Now, I'm going to take this problem. I'm going to put it on the next page with what I have simplified. But again, this is not a problem that we're going to be able to finish. Well, I'll finish it. I'll finish it, but you won't really have to worry too much about it. So what I did here was I did a keep, I did a change, I did a flip with what was left. Keep, change, flip with what was left. Very weird process. Ultimately, this x cubed plus 8, which again is it's something that, you know, I probably should not have assigned at this particular juncture. Should have been a junky thing like this. And then these x plus 2's should have canceled. Yeah. Ultimately giving you just this. Again, this is a weird problem. The problem being that x cubed plus 8 portion is not something that we really have focused on. It's not. And I would not really have to worry about it. So, no worries here. What I would like to do to wrap this up today is I would like to review a few addition-subtraction problems where you have to find the common denominator in order to get the problem done correctly. I want to get a few good examples here, because on your minor that I just assigned you today, you are going to have to do this kind of stuff. Okay. So, let's wrap that up with this. Make sure my battery life is okay. I'm at like 27%. Okay. So let's start with, let's start with this, something simple like this. Here's an example that you definitely need to see. 5 over 6ab minus 7 over 8a. With this problem, adding and subtracting, you're going to have to do this on the minor that I just assigned you today, something like this maybe, where you have to find a common denominator. Common denominator, now, they have a 6 and an 8. Hold on, I hear people screaming in the other room. Oh, they're okay. They're good. 6 and 8, in order to find the common denominator, you're looking at 24. You got to be up at a 24 for this. Now, they both have an A in common. We don't have to worry about that. But this one does not have the B. So, where's my red pen? I am going to multiply this particular problem by B over B in order to get that common denominator. The 6 and the 8, I need them both to be a 24. So I am going to multiply this first fraction by a 4 over 4 and this second fraction by a 3 over 3. Ultimately, the bottom of the fraction will be 24ab. Nick, take the pass with you. The top of the fraction, well, 4 times 5 is 20. Don't forget that minus sign. Multiply those three together, 21b. This is all you can do to this particular problem. The only thing that you can do to this particular problem. Because there were these monomials in the bottom of the fraction, you just had to worry about multiplying until you got the same denominator on both sides of the problem. Yes. Now, a more common problem that you're going to be faced with moving forward is something like this. Again, addition-subtraction problems. There we go. Now, with this problem, you have to assume parentheses around the bottom of these binomials. They clearly do not have the same denominator. You have to force them to be the same denominator. In order to force them to be the same denominator, you're going to have to multiply each fraction in order to force that denominator. If you multiplied the first fraction, and I'm writing this in red so you can see the clear distinction between the two. If you multiplied that first fraction by a minus 5 over a minus 5, that would force the first fraction to have a denominator of a minus 3, a minus 5. And if you multiplied the second fraction by a minus 3 over a minus 3, then that forces it to have the exact same denominator. When all is said and done, your denominator will just simply be that. But I do have to simplify the top of the fraction. The top of the fraction, I am going to have to distribute the 4 and the 9. It would give me a 4a minus 20 and a 9a minus 27. I'm going to have to combine like terms there, ultimately giving me a 13a minus 47, which is seemingly weird and wrong, but no, that's exactly what it should be. Always double check to make sure that you can, to see if you can factor any farther. It can't. That is my answer. Sometimes these problems are going to be very straightforward. Sometimes these problems are not. Let's do one more together. Let's do one more together. And then I'm going to call it a day on this particular stream, and I will have the timestamps available hopefully later this afternoon. You're saying yay for me being done, but you know, you're voluntarily being here. Oh, goodness. Joe, you say like 2 o'clock? Yeah, hopefully. Or 2 more? Oh, Joe wants 2 more problems. I don't know. What do you say, guys? Oh, goodness. Here's another addition-subtraction problem. There we go. Not yay to being done. Wait, what? Whatever. Anyway, but here's the problem. It's a subtraction problem. Keep in mind that subtraction, I need to have a common denominator. Your first step that you should always try to look for, see if you can factor. See if you can factor. Now, this particular quadratic can be factored into what looks like x minus 6, x plus 2. This first fraction already has an x minus 6. They do not have the same denominator. In order for them to have the same denominator, you're going to have to multiply that first fraction by x plus 2 over x plus 2. That's going to force both denominators to be the same thing, which is x minus 6, x plus 2. You're going to need to distribute. That gets you, what, a 5x plus 10? But then it's minus 20. So it really should be a 5x plus 10 minus 20, so really a 5x minus 10. But you should always double check. See if you can factor farther. This thing can be factored farther. You can take a 5 out of the top of that fraction. And you get something like this. Now, what's weird about that? You see the x minus 2 and the x plus 2. Sorry, I keep hearing noise out there. I feel like something's going on that I'm not aware of. Now, if I'm looking at this again, I could factor out the top of that fraction, but nothing else simplified. Nothing else simplified. There's nothing I could do. Yeah. Again, just to recap this problem. That's a weird symbol. Anyway, to recap this problem. The original problem is written in black right here. You can factor this quadratic to be x minus 6, x plus 2. Two magic numbers, add up to -4, multiply to -12, etc. They both have an x minus 6 in common. It needs an extra x plus 2 here in order to have the same denominator. If I do multiply that, here I get a 5x plus 10. But it's still minus 20. So it really should be minus 10. Take a 5 out as a GCF. But these don't cancel each other out. They don't. Because in order to cancel out, they have to be exactly the same. These are the types of problems you're going to have to do on that minor. Now, just for the sake of argument, one second. So to do these problems, I need to get the denominators to be the same. Yes. Like any other adding and subtracting of fractional problems. Like something silly. You can't do 2/3 plus 4/5. You can't just add them together. You have to have a common denominator. And in this case, the common denominator is 15. Where you would multiply, you would multiply this by 5 over 5 and multiply this by 3 over 3. Ultimately getting 10 over 15 plus 12 over 15, which gets you 22 over 15. It's the same exact concept, except you're dealing with variables and quadratics that you have to factor. Then find a least common denominator. I like them. Now, I would suggest reviewing not only this video, but other videos that I have posted in regards to these. I think in the description of the minor that I gave you, or in the instructions, there should have been multiple links to videos that you could have reviewed. I would suggest that you guys do that. Now, this concludes... No, you're not, Joe. This concludes the actual instruction of this particular live stream. Yeah. Yeah. I'll do one more cube for you guys before I go. So, Joe, one more problem or one more cube? Yay, 5 by 5, he says. What is this? Oh, where's my 5 by 5? There's my 5 by 5. I could do one more problem as well, if you want. I'm just scrambling up the 5. There we go. Scrambled. I usually average around a minute 45 with these. Well, Nick, I don't have any tutorial videos on right now. And my day is mainly filled with my work day is mainly filled with mathematics. So this would have to be an after hours type of thing. So maybe I'll do a tutorial at some point, but not at this moment. But I will go ahead and solve this thing. Here we go. Oops. Where is it? There you are. I haven't solved these in forever. What I really wanted to do at some point, I wanted to do a live stream of old school Nintendo video games, or a live stream of me trying to beat. I could do an N64 video game as well, but the quality of my streaming is not really that great. I'm trying to figure out how to make it faster. Nope. No, I'm not doing it that way. I don't feel like doing it that way. At a certain point, the big cubes is just a matter of don't worry about the algorithms. So, there we go. Whee! See, it's spinning there. It's also nice. Yeah, Nick, for the most part, yeah, kinda. You make the centers, you make the edges, you turn it into a 3x3, but then you have to be aware of any parity cases that you may end up getting, because parity cases are the worst. They just are. Anyway. I'm gonna forego the one more problem. I'm hungry. It's 11:40. I want to get some lunch, and you guys have been talking about food for like the last half hour, something like that. No, I would not do a private stream. Neither, Kyle. I have a Nintendo Switch. My goal, my ultimate goal, is to be able to purchase one of those. I don't even know what the machine is called, but it's like a machine that you can like plug the Switch into, and then it like you do like screen captures or video captures and stuff like that. I was trying to do that when I first got it. Yeah. He's talking about the 5x5 again. But anyway, going back to the video games. Because I wanted to speed run like Breath of the Wild or Mario Odyssey or something like that. Yes, thank you, Elgato. I mean, those are like, a good one, a decent one's like $80 or something like that or more, from what I saw. But yeah, I'm on a teacher salary. I can't really focus on that kind of stuff now. But anyway, I'm gonna end it there. I'm at like 8% on my phone, as my phone is my webcam, and I will have timestamps up later this afternoon for review. And yeah, we'll see you later. Like, share, subscribe.